ez a nagyfesztér a mérőkábelekkel, ebből egy részkisülésmentes kábel az L3-as.
Ja, a másik kettő az nem?
A másik kettő az nem, tehát ez egy komplett kábelhibájú mérő autó, ami ki van egészítve.
Hány méteres a kábel?
Diagnosztikára. Elvileg 50. Elvileg.
Kicsit problémás
For real, this is not necessary.
No,
hier ist es nicht notwendig, weil das geht direkt an den Koppler. Wir brauchen es für die Gegenseite, brauchen wir dann auch.
Hosszabbra van szabva az árnyékból, és Isten bácsi kábelét újra kell szabni.
Normally the VLF, which is the voltage source for the test equipment, has an internal discharging unit, but it's mechanical and just to be on the safe side.
Még időben?
Ja, ez a külső víz?
Valamelyikben volt, de
The system is operated by here. Just the selection to use the diagnose equipment is done by the centrics as well as the switching on and switching off of the high voltage. So that means this is the main starting screen of the centrics, like usual in the cake section mode. So here we have the diagnostic mode, and here we have the parcel discharge section. And now it tells us, okay, from here on we have to operate by the laptop. First step what we have to do is, because it's a new cable, we have to add that cable to our database. So we have measured 2 cables with the new system. So we have to add a new cable.
Yeah.
You can add a special type of cable, and you can add your experience of propagation velocity.
Very good.
Okay, so now the cable length also in the database. So now we have it exactly. So I save it. Okay, calibration saved. So we go out. Information that we have, or we should disconnect otherwise. And always, when we make a measurement, like also with the OWTS, we start with the 0 kV. So we make a background noise measurement. So we save it, and automatically it switches from noise measurement to a real parcel discharge measurement. And you see also for you as information we have done, okay, noise measurement check mark for phase 1. So you have a list, okay, what I have to do already. And here with the system you see we are able to have several voltage sources. We have a unit with two systems. We have the VLF cosine rectangular, so you can do the VLF testing, and during that test we are able to measure in the phase reversal, we measure parcel discharges. And we are able to do the damped AC measurement according to what the OWTS is doing. Like with the OWTS, we want to measure with the factors of the nominal voltage. So let's say, okay, it shows us we have to turn.
De akkor gyakorlatilag ez nem egy
And you see, the system tells us that the key switch was not turned,
megyünk
so
fölfelé
we have to
feszültséggel.
wait until
Most mondta, hogy igen, tudom, hogy csinált a
feszültségpróba alatt is.
Igen.
Mellékesen megkaphatod a részkísérést.
Now it's transferring the data by the gray cable, and we see our damped AC voltage, and we see, okay, more or less, it's the same noise level, or the same partial discharge level than during the noise measurement. So we increase, let's say 0.8. Start. So this is the same operation like with the OWTS. But you could also do, or you could tell the system, okay, I want to do 3 measurements. So you just press once and the system automatically shots 3 times, and you directly could save all the 3 shots in here. Easy. Nominal voltage. So here we have the first partial discharges. And already, okay, so this is our partial discharge inception voltage. So we save it as PDIV. Done. And we already recognize here a few dots at round about 80 meters per microsecond. So without doing anything, we already see, okay, most likely that could be our weak spot. So a few more shots. Already get more shots here. Safe measurement. There is a concentration, and it turns from light blue into dark blue, and you have the kind of a flag. This system is a digital unit, and we are we only have to calibrate once, and it's linear. So even when we have only one calibration level, it's giving us accurate levels for the higher partial discharge level and also for the lower partial discharge levels. And similar like with the OWTS, you can use the 1 calibration range for all 3 phases. 0.3. So it seems to be we have another concentration more or less at the end, but if the determination is the same like here, more or less it's maybe discharging to the cabinet or also like with the OWTS, we have to save the partial discharge extinction voltage for an accurate evaluation, an additional cursor, but here the software automatically jumps to the most recommended last pulse. And if I now would remove that cursor, you see, okay, and the noise measurement, we have saved the inception, we have saved the extinction voltage, so all done. Blue for L1, yellow for L2, and red for L3. But it seems to be the same location for that weak spot than for the L1 phase. I would say for the L3 phase we can also do it with the VLF, with the cosine rectangular. So you can see, okay, during the test you could also make the partial discharge measurement.
Producing the waves continuously.
Yeah. Sure.
So every 1 second or 2 seconds? What is the frequency? 10?
No, it's a VLF.
VLF,
0.1 hertz, so
0.1,
5
okay.
seconds positive, 5 negative.
Okay.
And only in the 2-3 milliseconds of the phase reversal we measure the partial discharges. But that's a good thing. You could do your VLF test for 60 minutes.
And then continuously collect the...
Yes, and additionally gets the information, okay, we have some weak spot here, and...
the voltage is now 1.3? 1.7. 1.7 means 1.7 DC?
No, 1.7 of the
effective
nominal voltage.
Nominal effective voltage.
Yeah, RMS.
RMS.
Because the accuracy is now much higher. Whenever it makes a phase reversal, it makes a measurement. And before only I made 2 or 3 shots. So we could select, okay, we just want to see our L1 for instance. So we have roughly 50 pulses here. And we could also make the evaluation directly, also manual, if we don't trust or we just wanna agree. And if you agree, okay, thumbs up. If you don't agree, thumbs down. Or if you are not sure, that means maybe it's an upcoming weak spot, then you say okay. And like you see here, it's always showing you which partial discharge you are now evaluating. And it's starting from the highest level, going down to the lowest value.
Nice software.
Is it a presentation or it's working?
No, it's real. It's really good. And
maybe it's only a slide.
and if you do the evaluation, and even for customers like you, yeah, they don't trust. We could add such pictures to our report. So you have the cable information. Yeah. It would be much longer if you have more joints in here. Then you could write down the recommendations already in here. You see the partial discharge inception and extinction voltage. PD max. Similar compared to the OWTS. Then you have the concentrations here up to the nominal voltage. Yeah. And then the concentrations for the higher test voltage.